This one won't work.
It's the presentation. Oh,
That's weird.
There we go. Okay. I can know we're ready to start now, guys. This is Drew. He's, as I said, I mentioned earlier, he's our first ever high school presenter at PLATEAU, which is pretty exciting. I hope we get this new trend. We're going to be talking about programming by example, efficient but not helpful. Good luck.
Thank you for that introduction. Good morning, everyone. I'm Drew, and today I'm going to talk about programming by example and an interesting user study we did. This study has been the joint work of Mark, my advisor Rujitsa, my high school teacher, and myself. So basically in this user study, we wanted to test the usefulness of a particular tool called StriSynth, which can be generalized to programming by example in general, and we wanted to test that against the traditional scripting tool, PowerShell. And we measured it in both their efficiency and their perceived helpfulness. So given that we're here at a computer science conference, most of you have probably scripted before, but to the people who haven't scripted before, scripting can be difficult, and I would like to start off with an example. So let's say you wanted to print all the PDFs in a directory, including its subdirectories. Essentially, the things I do want to print are the OOPSLA paper, as well as some figures from the PLATEAU paper, but I do not want to print the OOPSLA tech file. So as you can see, this task isn't terrible to complete if you know the proper commands and the syntax to piece it all together. But this can be a lot to ask from a novice programmer, especially if you don't know what you're doing. And of course, some programming tasks are even more involved. So let's say you wanted to take a list of files and construct hyperlinks for those files to access them quickly. So to explain the problem, we have a file.jpg, and we want to generate the HTML link for that file. And now we end up with a scripting task that is even more involved. It's something that we could certainly come up with by hand, but it would be very tedious to do so. So the logical question to ask here is, does there exist a better way to do this? And enter programming by example. What we looked at here was programming by example specifically for scripting. And this program that we use, StriSynth, comes from a paper in ICSI 2015. So StriSynth will allow you to provide examples of the functionality you're looking for in your script, and StriSynth will automatically generate the script that works in PowerShell. So if you refer to the previous two slides, we had examples of tasks we wanted to complete. So if you provide those examples to StriSynth, specifying what you want it to do and what you do not want it to do, it will generate the correct script in PowerShell. So if this was a normal programming by example talk, I would say, look, it has easy syntax, and everyone else is doing it and publishing papers on it, and flash fill, which is one of the classic success stories of programming by example. And actually, we were working under those same assumptions, but after completing this study, we asked the question, will programming by example actually solve all of your problems? So, as our goal of the study, we asked two questions. The first one, we asked, is StriSynth and programming by example more efficient than PowerShell? Adding on to that, we asked the question, is StriSynth and programming by example a tool that real-world users actually want to use? And at first glance, these two questions appear to be pretty similar. But after completing this study, are they really? So I'll give you a brief background of the study design so you can get an idea of what exactly the participants were doing. So we recruited 27 participants who were mostly IT professionals from Long Island, and we gave them a tutorial to do in both PowerShell and StriSynth so that they had a relatively even background of the two tools. And then we gave them 3 relatively straightforward scripting tasks to do in both PowerShell and StriSynth. And after that, they completed a post-study questionnaire. So we actually ran the study in person, and each participant used our laptop, or should I say my laptop, to complete the study. Now, we did this to ensure that all the conditions were the same. I mean, you wouldn't want one participant using a desktop with access to a mouse and a keyboard and another restrained to a laptop, because that could foster bias. Now, we decided to tell the participants that we created both tools, that we created PowerShell and StriSynth. And also, we gave the name StriSynth A to PowerShell, while we gave the name StriSynth B to StriSynth. And we did this to eliminate this need to please bias among the participants, which is basically the natural tendency for participants to favor the researcher's tool over the traditional tool. So we also implemented a counterbalance design where we grouped participants into two groups, Group A and Group B, about half in each, 12 and 15. And the participants in Group A completed the tasks in PowerShell first, while the participants in Group B completed the tasks in StriSynth first. And after completing their 3 tasks, they swapped programs and then completed the other 3 tasks in the opposite program. And we did this to eliminate the confound of the order in which the tasks were completed. Finally, all the materials for the study are online, so if you would like to do some analysis on the data or replicate the study, here's the link, and you can feel free to talk to either Mark or me afterward. So our first data analysis indicated that programming by example is more efficient than scripting. If you've heard of the legend, the black bars represent the time it took the participants to complete the tasks in StriSynth, while the white bars represent the same for PowerShell. But in this case, the shorter bars are better because they indicate the greater efficiency, which is evident for StriSynth. We also found a statistically significant difference in task 2 move files and task 3 printing PDFs, which basically means we are pretty certain that the results were not due to chance and they were indeed due to the difference between the 2 programs. Another thing to mention here are these error bars. Basically, the error bars will give us an indication of the true mean, and we only selected a sample of 27 participants, but we can be pretty certain that the true mean lies somewhere in that range. Now, these results aren't too surprising. I'm sure everyone has seen the classic programming by example is more efficient than the traditional scripting. But then, in the first study survey, we asked the participants, which tool did you find more helpful? And we recorded these responses on a scale from 1 to 7, 7 being the most helpful. And the interesting part about these results is that although the participants completed the tasks more quickly in StriSynth, when asked which tool is more helpful, they actually said PowerShell, the less efficient tool, is more helpful. Now, once again, the white bars represent PowerShell while the black bars represent StriSynth. But in this case, the taller bars are better because they represent a greater efficiency. So because we found these seemingly contradictory results, we wanted to do some digging to find why the participants would be more efficient in one program and rate the other as more helpful. So to give you some background on the users, these were real-world users. These were not participants in PhD programs or universities. But the users did have some experience in these scripting languages. If you refer to the PowerShell histogram, you can see that a majority of the users had at least some experience in PowerShell. If you could categorize some as a 2 to a 7 on the experience scale. And even if you look at the 10 participants who said that they had no experience in PowerShell, if you look at Bash and other scripting languages, some of those 10 actually did have some experience in other languages. So it's not like these participants came into the study completely blind. Now, this is significant because despite the participants having some prior experience in PowerShell, they still completed the tasks more quickly in StriSynth. So then we might ask, is prior experience a factor in how helpful they rated the program to be? But actually, when we isolated prior participant experience level and we graphed the results, we saw very similar trends. The participants were still completing the tasks more quickly in StriSynth, and the participants still rated PowerShell as more helpful. So we can be pretty certain that our participant experience didn't have much of an impact here. So the question that we're asking here is, how are efficiency and helpfulness different? And there are a few possible explanations. The first thing it might be is maybe the interface of StriSynth just isn't as helpful as that of PowerShell. And I know certainly if I was using a program and I felt more comfortable with one interface over another, I'd most likely be more inclined to rate it as more helpful. But actually, the StriSynth interface is pretty similar to PowerShell's. Both of them are embedded in a command line, and essentially what you're doing is you're typing into a terminal when you're using them. So then you might say, well, I'm using programming by example. I've given it a few examples, but I don't know if I actually created the correct script. And certainly that could be an unhelpful feature of programming by example. StriSynth uniquely, however, has a nice feature where after you've done your programming by example portion, it will generate an English description of what the synthesized program is going to do. And given that everyone has a slightly different style of English, we don't know exactly how helpful this feature is, but the result is there. So then it could also be this perceived lack of control. Maybe StriSynth just isn't an expressive enough paradigm, whereas in PowerShell you can create almost anything you want and there are much less restrictions. Finally, it might just be that programmers actually enjoy programming. The reason people join the industry is to solve problems and code, and maybe people just don't like us taking that freedom away from them. So after completing this study, we came up with a few tips for future user studies. The first thing we came up with is it's important to measure as much as possible. Since running a user study has such a high cost, both in money and time, it's important to make the most out of your participants' time that they're giving you. So if you could extend a participant's time by 5, maybe 10 minutes to record some more data, it is 100% worth it. You never know what data you're going to end up needing down the road. Secondly, it's very important to address this need to please bias for the participants. Since users are biased toward the researcher's tool, it's important to present both researcher's tool and the traditional tool as your own, so that the participants aren't biased. And if we didn't present both tools as our own, we might have not gotten the interesting results that we did. Finally, it's important to address a selection bias. You really want to choose a representative sample of the population. So if you choose a sample of all PhD students or university students, odds are that they're going to be experts in whatever you're testing, and they're not going to be entirely representative. So it's important to reach out to real-world users, people who would be using this in the real world. For further study, it would be interesting to see what exactly the participants perceived the word helpfulness as. Unfortunately, in this study, we weren't at all expecting these results. So we didn't ask any follow-up questions. When we asked the participants which tool you found more helpful, we didn't ask why. And that would be an interesting thing to dive deeper into. Another question is, how does this idea of efficiency versus helpfulness transfer to other domains of programming by example and ultimately program synthesis? And finally, for the community, we should be asking what important benchmarks should we be using? In this case, we decided to use efficiency and helpfulness, but in another study, we might use the speed of the program. So there's certainly more here than what we asked in our study, but going through this entire experience, it was definitely interesting, and we found some really interesting things. And with that, I will conclude my talk, and I will be glad to answer any questions.
Guys, go ahead. I'll let you actually choose the notes. It's going to be scary.
The result that they found what they were more familiar with, helpful might be related to a result I've seen in syntax for C++ programmers. People that are really experienced with C++ find the syntax of C++ more pleasing, let's say, more normal than users that are starting out with programming. Maybe that is kind of the bias that came in to have them rated more helpful in the survey. It's like they're familiar with it, so they like it more. They recognize it probably, even if they use it before.
Yeah, we definitely considered the aspect that they felt accustomed to PowerShell as a reason. I definitely think that's a possible reason.
Did you record any qualitative data that might let you might help you answer these questions of what do users mean by helpfulness? And in particular, I'm wondering about, so one possibility is people who were using a programming environment felt like they were, really serious, good programmers, and it made them feel sort of positive about themselves. Or alternatively, people thought rationally that a programming tool would be more generalizable and more applicable in more situations, and that's why it was more helpful. Do you have any sense as to which it might be, or do you have any data in which you could reason?
So on our study, we recorded mainly quantitative results, and that's one of the weaknesses that we didn't dive deeper into. It would have been nice to ask why the users felt that way, or get some insight as to how they were feeling as they completed the tasks. Since we only asked questions on number scales and got quantitative results, we were kind of limited in that aspect, but it would be nice in a further study to see exactly what the users were thinking as they completed the questionnaire.
What qualities did you want to emphasize in the tasks that you presented to the users?
So we picked pretty relatively straightforward tasks. The three tasks that we chose, very simple tasks, any everyday task that someone would do, moving a bunch of files, printing PDFs. Basically, we wanted the users to just have a simple grasp of each language. We weren't looking for any particular skills, but just to see how completing a simple task in each program would transfer between the programs.
So I think there are two surprising results. One is the fact that helpfulness and efficiency seem at odds. The other thing that's surprising to me on this graph is that StriSynth is not that much faster than PowerShell. It's faster, but it's not like everybody should be using this.
Yeah.
And I was curious if you could characterize a little bit about what the experience in StriSynth was like for the users, and if there was anything from this that suggested how you can kind of continue to increase the delta between those bars.
So the users were exposed to about a 10-minute tutorial in PowerShell first, and then StriSynth. So when I was administering this, when we were administering the study, I noticed the participants felt a little lost on the first task for StriSynth, and by the second and third tasks, they kind of got a little more used to it. But I think part of this had to do with the fact that they weren't exposed to StriSynth at all. But after the tutorial in the first task, kind of moving along, they got a better grasp. But in the future, definitely giving them a longer tutorial might help increase that delta.
What did you use to incentivize the developers to participate in the study?
We gave them a $5 incentive.
I have a question, actually. So, actually, this is a long one of the many studies that found a similar result, that people don't like the tool that is more efficient. And in fact, you can see examples of it in much more dramatic results. Actually, my thesis part of my thesis had a similar study where we found a 12x difference in time, and people still like the status quo tool more than the innovation. And one thing we found in that particular case, and this is true broadly, and it may be true in this case, it's not one of the hypotheses you mentioned, is that people's affinity to things seems to have a lot to do with just visual pleasure in the interface, right? Does it look good? And so it was certainly an indication of my thesis. I ended up redesigning, like, I had a friend that was a graphic designer, and I asked them to improve the interface, and the numbers changed completely just by that small change. So I don't know what StriSynth looks like, but it maybe just people feel like it's a research prototype, not a real product, and in a way where PowerShell feels like a real product, because it in fact is a real product. And that kind of thing have a big impact. I guess the lesson I know I'm sort of asking a question, I'm really making a comment to the audience. The lesson I learned from all this is that it's sort of useless to ask people whether you prefer the research tool, because it's almost impossible for researchers to invest enough time to compare a research tool to like a status quo, to a tool made by Microsoft or some similar organization. They're always going to have more designer time and more HCI people working on things, users doing user evaluations. That being said, there's the question I have for you after all that, like, what do you think there's something in your case that you StriSynth could have done to improve the situation that would have made people feel like they like it more?
Well, actually, StriSynth is built on top of PowerShell.
Okay.
So both of the tools are very similar.
Visually the same.
Basically, visually the same. I think in our case, us calling both tools StriSynth A and StriSynth B, participants didn't really know the difference between them. However, them being more accustomed to scripting by hands definitely might have had something to do with it. I think it's possible that StriSynth is different from PowerShell in the regard that it has instructions of how to use it, and maybe participants just felt too constrained while using StriSynth.
Do you think there's if you go back to Andrew's question, is there a task you could have given them where people would have felt like, well, wow, this is the thing that really is going to be much easier in this environment, and I could have, for doing this specific thing, it would have been, it's a lot better. I really see the value of it.
Well, I think any sort of task that's really repetitive, that programming by example can conquer in a short time versus having to repeat it, would be useful for programming by example. In our move files task, we had them move 26 files, so we tried to kind of see if programming by example would display it in that way.
Okay. Sounds good.
So you're in high school. Thank you very much for coming along. What's your next steps? Where are you going to plan to go to college?
So I am applying to schools right now. Applying to Yale. Carnegie Mellon is one of the schools I'm really interested in going into computer science in the future. I don't know exactly where I'm going to go, but I hope I can continue studying this in college, regardless of where I go.
Sounds good. Any last questions? Okay, thank Drew.